Welcome. In my grading system, points can come from three places. Participation, which means putting yourself in a position to learn, learning from experience, and by performing, which means demonstrating that you have learned the material. Now on this quiz, because I knew the problems were fairly challenging, I put all the points on participation. So if you took the quiz, you got 10 points because, hey, you got to be in the swimming pool in order to learn. And I did mark your level to tell you how you're doing in terms of your learning. So level 0, level 1, level 2, level 3, etc. The purpose of the first problem was to measure how well have students learned the continuity equation. And the problem I gave you was problem 590 out of 10E, and it's listed here. This shows how to solve the problem, and the key idea is figure problems out by applying main equations. So as we look here, I start by defining a control volume. I define it, and I'm going to use a deforming control volume. And I see that I have a mass flow rate out, and the accumulation term is negative because I'm losing mass as the exhaust gas flows out, and the mass in the control volume can be written as the product of the density of the gas times the volume inside the cylinder. So that's this volume right here. There's no inflow, so this term is 0. The outflow is given, so this term is known. And the mass of the control volume I replace with the density times volume. The reduced equation is right here. And the density of the gas in the chamber, the density right here, I would expect to increase because the gas is being compressed. And the volume of the control volume is going to be decreasing because the piston's moving upward. So I expand this term out with the product rule and get two terms there. I can calculate density with the ideal gas. I can calculate the change in volume of the cylinder with respect to time because I know the piston velocity. I have parameters for calculating the volume of the control volume at this instant in time. The change in density with respect to time is my goal. And I have an equation for the rate of mass flow out, so I can calculate this term. Oh, one equation, one unknown. I guess this problem is solved. And this whole analysis, once you understand the ideas, is about 2 or 3 minutes to do. In case you want to see how the numbers worked out, I programmed this in MATLAB, solutions laid out here, and you can pause the video and look at how the calculations are done and what the numbers are. Here is the solution, and here's the intermediate calculations. Here's an example of how I scored one student's work. So there's 10 of 10 points for participation for simply being in class. You can't learn to swim unless you're in the swimming pool. And we see some good stuff going on. We see a sketch of a control volume, could be labeled, but at least we see the sketch. We see mass flow rate out right there. We see the general form of the continuity equation. We see that it's reduced down and then analyzed correctly. And then we see that the student has calculated over here the rate of mass flow out. So put numbers into this equation and gotten the right answer. And if you look at this carefully, you'll see that the unit analysis is not done correctly, but at least they're carrying and canceling units. So there's some good things going on here. But what I don't see is any analysis of the accumulation term. And this is key to solving the problem. As a matter of fact, you can't get at the goal unless you analyze this term, as I just showed you. So what I think here as I look at this is, where's the physics? And instead of seeing an analysis of the problem, what I really see primarily is plugging numbers into the given equation. And you might see on your paper dead-ended skills, ? And what this means is your solution appears to me like you might be using skills that'll never work in the real world. So dead-ended skills basically are plugging numbers into equations without basic understanding of the physics. And if you're using this solution approach, I'd like you to reconsider how you're doing things. So the scoring on this problem is level 1. And remember, the key idea, you can't get to level 3 unless you have the physics basically correct. And so I did not see the physics on here even analyzed. And so that's the primary reason it's down at level 1. So what did the data show? The data showed that 100% of the students were between level 0 and level 2. The data showed that none of the students had the physics down, or what that means is they may have had the physics down, but it wasn't apparent from what was written on the sheet of paper. And of course, this is a really simple idea. Accumulation equals inflow minus outflow. So of course, all students can get this. So the path for growth, how to get better, is to apply the engineering process. Make the key sketch, look at the physics, accumulation equals outflow minus inflow. Start with the general equation, term-by-term analysis, and come down and analyze your final reduced equation. Very straightforward. The second quiz problem was to measure how well have students learned Newton's second law of motion. And so the basic task is given here. And of course, the second law is super important in engineering. So I went over the problem in class, and there's two key things that one has to do. One, idealize the problem, and just take that hammer and make it a particle rotating in circular motion, and then apply F equals ma. So start with sum of forces, draw a free body diagram in the usual way, and then analyze the acceleration. And hey, acceleration only has two components. If the particle's on a curved path, there will be a component of acceleration inward, so long as the particle's moving. And if the particle is speeding up or slowing down, there will be a component of acceleration tangent to path, and there's the inward to path. And now we can see we have forces and accelerations, so you just write the scalar equations right there. Very straightforward. The data showed that 100% of students were between level 0 and level 2. So this shows that none of the students yet have got F equals ma down. The path to growth, again, is just applying the engineering process. Start with the main equation. When we analyze forces, we do a free body diagram. And when we analyze accelerations, we do a kinetic diagram. And then you just equate these scalar components to get this equation and this equation. Very straightforward. I'd like to summarize some of the things I've been teaching you. What the researchers say is that people excel, which means getting insanely good at things, by choosing to do smart things or choosing to do wise things. And what this means is that all of you can excel, and it's just simply a matter of choice. So, how do I excel? I find something about engineering that I love. Alternative energy, structures, design, whatever. Then I ask the question, how can I connect this class to what I love? So this class is about me and not about grades or the teacher or any of that stuff. And this, of course, is an iterative process. How can I excel? Part 2, and this is getting knowledge down, or GKD. And step 1, I can choose to be open-minded. Maybe all those really smart people who have been doing this for many years have learned something that would be useful to me. Perhaps if I learn that, I can get better. Then I can find this knowledge and get the knowledge figured out, and then just apply this knowledge. And of course, this is a highly iterative process. How can I excel? Well, I can choose to learn from experience, which I abbreviate as life. And it's the natural way to learn. And we all kind of know this. First off, I've got to do it myself. Then get feedback from my teachers, from the world, is what I'm doing working, and then reflect and grow. And like all the other processes, this is very iterative. All right, you can learn from experience or grow right now. Here's how you do it. Just think back on this quiz plus the feedback and ask yourself the question, what are 5 super useful ideas that I learned from this experience? And then very importantly, write these ideas down. The writing is critical. Hope you've enjoyed this video. We'll see you next time.